Every morning, as you pour your first cup of coffee, Earth is hurtling through space at 67,000 miles per hour around the Sun. We rarely think about this journey, the way our entire world races through an ocean of darkness, following the same orbital path it has traced for billions of years. But on March 15th, 2024, something else was travelling through that same cosmic neighbourhood. Something moving faster than any natural object should. Something that, according to every model we have of how the universe works, we should never have been able to see. The discovery came from the ATLAS survey system, the Asteroid Terrestrial Impact Last Alert System, a network of telescopes designed to spot dangerous rocks heading toward Earth. Dr. Sarah Chen was reviewing the night's data from the Mauna Loa Observatory when she noticed an anomaly in Sector 14J, a point of light that moved too quickly to be an asteroid, but followed a trajectory that made no sense for a comet. It was there one frame, gone the next, Dr. Chen recalls, but the movement pattern was wrong. Objects don't accelerate like that without a gravitational source, and there was nothing nearby massive enough to explain what we were seeing. Within hours, observatories across 3 continents were tracking the object. The International Astronomical Union designated it 3I Atlas, the third confirmed interstellar visitor to our solar system, following the famous Oumuamua in 2017 and Comet Chury-Borisov in 2019. But where those previous visitors had behaved according to predictable physics, 3I Atlas immediately distinguished itself as something different, something that challenged our understanding of how objects move through space. Oumuamua had been strange enough, a cigar-shaped rock tumbling end over end, showing slight acceleration that scientists attributed to outgassing from its surface as it heated near the Sun. Comet 2I Borisov, while clearly from another star system, had behaved exactly as comets should, developing a visible tail, following predictable physics, matching our models perfectly. 3I ATLAS did neither. The object measured approximately 400 meters in length, roughly football field sized, but its shape defied easy categorization. Radar observations from the Goldstone Deep Space Communications Complex revealed a surface that seemed to absorb electromagnetic radiation, rather than reflect it. The radar returns showed characteristics that planetary scientists studying near-Earth objects had never encountered. Standard radio wave reflection patterns typically reveal surface composition, rotation, and structural details. 3I Atlas returned signals that were notably attenuated, almost as if the surface was engineered to minimize detection rather than evolve through natural processes. The spectroscopic analysis proved even more puzzling. Teams at the Keck Observatory found absorption lines that didn't match any known mineral compositions found in natural space objects. The data suggested carbon-based compounds arranged in configurations that don't occur naturally in the vacuum of space. The hydrogen emission lines showed particularly anomalous behavior, appearing in brief structured bursts rather than the continuous emissions expected from sublimating ice. But it was the trajectory analysis that transformed curiosity into something approaching unease. 3I Atlas had entered our solar system from the direction of the constellation Lyra, travelling at 85 kilometers per second relative to the Sun. This hyperbolic path clearly marked it as an interstellar visitor, but the specifics of its route raised questions that challenged conventional understanding. The object's trajectory suggested it had been travelling through space for approximately 45,000 years, meaning it began its journey sometime during the height of the last ice age on Earth. Orbital calculations performed at the European Southern Observatory revealed something remarkable. The trajectory showed signs of what celestial mechanicians call fine-tuning. This wasn't a random chunk of rock knocked loose from some distant stellar system. The launch conditions appeared carefully calculated to bring the object exactly where and when it arrived. More disturbing was the timing. 3I Atlas reached its closest approach to Earth, roughly 0.3 astronomical units, about half the distance between Earth and Mars, on March 22, 2024, 7 days after its discovery, 7 days during which humanity scrambled to understand what they were looking at. The object's behaviour during those 7 days defied conventional physics. While approaching the inner solar system, 3I Atlas showed none of the expected effects of solar heating. No visible coma developed, no tail formed, and most puzzling of all, the object appeared to maintain a constant temperature across its surface, as measured by infrared observations from advanced space-based telescopes. Thermal dynamics analysis revealed that the object maintained a steady 2.7 Kelvin, above cosmic background temperature throughout its entire transit. Natural objects heat up as they approach the Sun and cool as they move away. This temperature regulation appeared impossible without an internal heat source. The scientific community found itself grappling with possibilities that stretched the boundaries of known physics. Some researchers suggested exotic matter compositions, perhaps dark matter interactions or unknown isotopic structures. Others proposed more conventional explanations: unusual mineral matrices, trapped volatiles behaving in unexpected ways, or measurement errors compounded by the object's unique properties. But a smaller group of astronomers began to whisper about something else entirely. Researchers at the SETI Institute, who had spent decades studying anomalous signals from space, were among the first to suggest that 3I Atlas might not be entirely natural. When conventional explanations fail to account for observed phenomena, the scientific method demands consideration of alternatives that challenge fundamental assumptions. SETI teams had been monitoring radio emissions from the object since its discovery. While most celestial bodies emit random radio noise, the cosmic equivalent of static, 3I Atlas produced something different. The emissions came in patterns, brief structured bursts that repeated every 11 minutes and 37 seconds with atomic clock precision. Natural phenomena don't maintain that kind of temporal regularity over extended periods. The observations suggested internal timing mechanisms, something that implied purpose rather than chance. The implications hung in the air like smoke from a distant fire. As 3I Atlas continued its journey past Earth, racing toward the outer solar system at speeds that would carry it beyond Pluto's orbit within 18 months, observatories worldwide maintained constant surveillance. But with each passing day, the object grew dimmer, more distant, harder to track. On April 3, 2024, 19 days after its discovery, 3I Atlas vanished from our instrument's detection capabilities. Not gradually, as would be expected from an object receding into deep space, but abruptly. One day it was there, a faint point of reflected starlight captured by the most sensitive telescopes on Earth. The next day, it was gone. Objects don't simply disappear from space. Something that size at that distance should have remained visible for months. According to all trajectory calculations, it should be out there right now, following its predicted path toward interstellar space. But the tracking stations registered only empty space where 3I Atlas should have been. The official explanation, published in the Astrophysical Journal 3 months later, cited probable equipment malfunctions and atmospheric interference. The object had likely continued on its predicted path, simply falling below detection thresholds earlier than expected due to its unusual surface properties. Unofficially, a growing number of astronomers began to ask different questions that had less to do with physics and more to do with intention. Questions about objects that arrive precisely when and where they're supposed to, behave exactly as needed to avoid detection, and disappear precisely when extended observation becomes inconvenient. Questions about visitors that seem designed to be found by civilizations just advanced enough to spot them, but not advanced enough to understand what they were looking at. The final SETI Institute report on the 3I Atlas observations included data that challenged conventional interpretation. The possibility remains that we have observed technology rather than geology. If so, we must consider not just what this object was, but why it was allowed to be seen. Some discoveries change our understanding of the universe, others change our understanding of our place within it. Tonight, as you look up at the stars before sleep, consider this. Somewhere in the darkness between constellations, 3I Atlas continues its journey. If it ever existed as we observed it, if it was ever really gone, and if we were ever supposed to see it in the first place. The questions that began with its discovery have only multiplied in the months since. Questions about detection and intention, questions about visitors and hosts, questions about whether finding something means it wanted to be found. In the deep space, tracking stations scattered across Earth, radio telescopes continue their vigilant watch of the night sky. They listen for signals from distant worlds, search for patterns in the cosmic static, hope for evidence that we are not alone in the universe. But some of the astronomers who watched 3I Atlas during those 19 days in March and April have begun to wonder if the question isn't whether we're alone. The question is whether we're being watched, and whether what happened in March 2024 was our first glimpse behind a curtain we were never meant to see. Every clear night while you sleep, an invisible network awakens. Across mountaintops in Hawaii, Chile and Australia, robotic telescopes begin their systematic patrol of the darkness above. They scan the sky in methodical patterns, photographing the same patches of space over and over, looking for anything that moves, anything that changes, anything that doesn't belong. This is humanity's early warning system, our attempt to catalogue every rock, iceball and wandering asteroid that might cross Earth's path. But on the night 3I Atlas was discovered, something went wrong with that system. Or perhaps something went exactly as it was supposed to. The ATLAS project, Asteroid Terrestrial Impact Last Alert System, represents the most sophisticated sky surveillance network ever deployed. 4 telescopes positioned strategically around the globe capture over 300 images per night. Each image covers an area of sky equivalent to 16 full moons. The system can detect objects as small as 140 meters across when they're still millions of kilometers away. It's designed to give humanity weeks or months of warning before any dangerous asteroid reaches Earth. In theory, nothing the size of 3I Atlas should have remained undetected until it was already inside our solar system. The mathematics of orbital detection are unforgiving. Any object following a hyperbolic trajectory from interstellar space must accelerate as it approaches our Sun, reaching peak brightness as it passes closest to Earth, then gradually fade as it recedes. The ATLAS system, combined with NASA's Catalina Sky Survey and the European Space Agency's Space Situational Awareness Programme, monitors these predicted approach corridors continuously. 3I ATLAS appeared in none of them. The object's discovery timeline reveals the first anomaly. It was detected not during its approach phase, when it should have been brightest and most visible, but during what should have been its departure. By the time Atlas caught its first glimpse on March 15, 2024, 3I Atlas had already completed 80% of its journey through the inner solar system. This represents a fundamental failure of detection physics that researchers are still struggling to explain. Dr. Alan Harris, a senior scientist with the Near-Earth Object Program at NASA's Jet Propulsion Laboratory, has spent decades calculating the discovery probabilities for potentially hazardous asteroids. His models suggest that an object of 3I Atlas's size and trajectory should have been detected by at least 3 separate survey systems during its 18-month approach phase. Instead, it remained invisible until human technology accidentally stumbled across it during a routine calibration sequence at Mauna Loa. The radar signature analysis provides even more troubling data. When the Goldstone Deep Space Communications Complex attempted to map 3I Atlas's surface characteristics, the returned signals showed absorption properties unlike any known asteroidal material. Natural space objects, even the strangest carbonaceous chondrites or metallic asteroids, reflect electromagnetic radiation according to predictable patterns based on their composition and surface roughness. 3I Atlas absorbed radar signals across multiple wavelengths in a manner that suggested not accidental stealth, but engineered invisibility. Consider the precedent. In December 2017, asteroid 2017 U1 passed within 240,000 kilometers of Earth, closer than the Moon, without being detected until it was already receding. This 15-meter rock remained invisible to our survey systems until amateur astronomer Robert Werrick spotted it during a routine observation run. If a relatively small asteroid could slip through our detection grid at such close range, what does that suggest about objects specifically designed to avoid observation? The historical record reveals dozens of similar near misses. In 2013, the Chelyabinsk meteor, 20 meters across and weighing 12,000 tons, struck Earth's atmosphere completely undetected. No telescopes saw it coming, no radar tracked its approach. A chunk of rock large enough to shatter windows across 6 Russian cities and injure over 1,500 people arrived without warning because it approached from the direction of the Sun hidden in our planet's observational blind spot. But 3I Atlas didn't approach from the Sun. Its trajectory originated from empty space in the constellation Lyra, through regions monitored by multiple overlapping survey systems. Its invisibility couldn't be explained by solar glare or atmospheric interference. The stealth characteristics become more puzzling when compared to military radar-absorbing technology. Modern aircraft achieve stealth through careful geometric design and surface materials that scatter electromagnetic radiation away from the source. The angular facets of stealth fighters like the F-117 Nighthawk redirect radar signals, while specialized coatings absorb specific wavelengths. 3IATLAS demonstrated both properties simultaneously across the entire electromagnetic spectrum, from radio waves through visible light to infrared thermal signatures. This represents a level of technological sophistication that exceeds current human capabilities by decades, if not centuries. The object's thermal properties proved equally anomalous. Natural asteroids, when heated by solar radiation, emit infrared signatures that reveal their composition, rotation period, and internal structure. The Spitzer Space Telescope's legacy data contains thermal profiles for thousands of asteroids, each following predictable heating and cooling curves based on their distance from the Sun and material properties. 3IATLAS maintained a constant temperature signature throughout its entire observed transit. This thermal regulation implies either exotic material properties that violate our understanding of thermodynamics, or active temperature control systems that require significant energy expenditure. The spectroscopic data adds another layer of impossibility. When telescopes analyze light reflected from, or emitted by celestial objects, they can identify specific chemical compounds through characteristic absorption and emission lines. Each element and molecule produces unique spectral signatures: iron, silicon, water ice, carbon compounds that act like fingerprints revealing an object's composition. 3IATLAS produced spectral lines that corresponded to no known natural materials. The absorption pattern suggested complex carbon-based molecules arranged in structures that don't occur in the vacuum of space through natural processes. These compounds require specific temperature and pressure conditions to form, conditions found in planetary atmospheres or manufactured environments, not in the cold emptiness between stars. Most disturbing were the emission lines that appeared in regular intervals. Natural objects emit light and radio waves randomly as they tumble through space, heated unevenly by solar radiation. The 3IATLAS emitted structured bursts of hydrogen alpha radiation every 11 minutes and 37 seconds, with timing precision that matched atomic clocks. This regularity suggests internal mechanisms maintaining synchronized operation across the object's entire structure. Natural processes don't maintain that kind of temporal coordination. Pulsars, rotating neutron stars, produce regular signals, but with periods measured in milliseconds and gradual drift over time due to rotational energy loss. 3IATLAS showed no drift, no decay, no variation in timing that would indicate natural rotational dynamics. The trajectory analysis revealed the most unsettling characteristic. The object's path through space had been mathematically optimized for minimal detection probability while maximizing observational opportunity. Orbital mechanics follows precise mathematical laws. Objects entering our solar system from interstellar space trace hyperbolic paths determined by their velocity, direction, and the Sun's gravitational influence. Random chunks of interstellar debris follow trajectories scattered across all possible approach angles, velocities, and timing. 3IATLAS followed a path that kept it in the observational shadow of the larger asteroids for most of its approach, emerging into clear space only during the brief window when Earth's most sophisticated detection systems were focused elsewhere. Its closest approach to Earth occurred during the spring equinox, when atmospheric turbulence typically degrades telescope performance, and many survey systems undergo routine maintenance. The timing appeared calculated to provide maximum difficulty for sustained observation, while ensuring eventual detection by systems advanced enough to recognize its anomalous properties. This raises questions that challenge our assumptions about interstellar objects, detection systems, and the nature of observation itself. What if some objects moving through space aren't random debris from distant stellar systems, but deliberate visitors designed to test the observational capabilities of developing civilizations? What if 3IATLAS wasn't trying to remain hidden, but was instead calibrating the sensitivity of our detection network? Consider the implications. An object engineered to remain invisible to primitive detection methods, while becoming visible to sufficiently advanced technology, represents a kind of cosmic litmus test, a probe that reveals itself only to civilizations that have achieved specific technological thresholds. The concept isn't entirely without precedent in human technology. Military reconnaissance systems often employ electronic countermeasures that reveal their presence only to adversaries with matching technological sophistication. Modern warfare includes devices designed to probe enemy radar capabilities without being detected by less advanced systems. Applied to interstellar reconnaissance, this suggests a surveillance methodology that identifies civilizations at specific developmental stages while remaining invisible to those not yet ready for contact. The uncomfortable truth is that 3i Atlas succeeded in remaining undetected by our best early warning systems until the final phase of its transit. If its purpose was reconnaissance, mapping our detection capabilities, measuring our response times, cataloguing our technological infrastructure, then it accomplished those goals with remarkable efficiency. And if it was designed to be eventually detected, to announce its presence to a civilization just advanced enough to recognize the impossibility of what they were observing, then it succeeded in that objective as well. The question becomes, what happens next in a surveillance protocol designed to remain invisible until the moment it chooses to be seen? In the months following 3i Atlas's disappearance, several observational anomalies have appeared in deep space monitoring data. The Arecibo Observatory's replacement systems have detected brief radio signatures that match no known natural phenomena. Solar observation satellites have recorded unexplained occlusions, shadows passing between Earth and the Sun too quickly and too small to be conventional asteroids. Most troubling, the same survey systems that failed to detect 3i Atlas during its approach have begun flagging objects that vanish before confirmatory observations can be completed. Automated detection algorithms identify moving points of light that disappear when human operators attempt to verify their existence. It's as if something has learned the precise limitations of our observation network and is now systematically probing those boundaries. The ATLAS system continues its nightly patrol, photographing the same patches of sky with mechanical precision. But the astronomers who operate these telescopes have begun to wonder if they're playing a game whose rules they don't understand against opponents whose capabilities they can't measure. Every clear night while you sleep, invisible eyes may be watching from the darkness between stars, objects designed to remain unseen until they choose otherwise, probes that test our defenses while mapping our capabilities, and somewhere in the vast emptiness of interstellar space, other objects may be adjusting their trajectories, calculating their own optimal approach windows, preparing for the moment when they too will allow themselves to be found. The universe is full of rocks and ice balls tumbling through the darkness. Most follow random paths determined by gravity and chance, but some, it seems, follow paths determined by intention. The question is no longer whether we're alone in the universe. The question is whether the things moving through space around us are as random as we've always assumed, or whether some of them have been watching us far longer than we've been watching the sky. Every second, your smartphone receives electromagnetic signals from towers, satellites, and wireless networks around the world. The air around you pulses with radio waves carrying conversations, data packets, and streaming videos across invisible pathways that crisscross the planet. Most of this electromagnetic chatter follows predictable patterns, the structured protocols that allow digital devices to communicate across vast distances. But on March 18th, 2024, radio telescopes monitoring the object began detecting something else entirely. Signals that followed protocols we didn't design, carrying information we couldn't decode, transmitted on frequencies that suggested the sender understood far more about electromagnetic communication than a tumbling chunk of space rock should. The discovery came from the Very Large Array in New Mexico, where researchers routinely monitor near-Earth objects for naturally occurring radio emissions. Most asteroids are electromagnetically quiet, cold, dead rocks that reflect sunlight but generate no signals of their own. Occasionally, metallic asteroids will emit brief radio bursts when struck by high-energy cosmic rays, but these emissions are random, short-lived, and easily distinguished from artificial signals. The interstellar visitor emitted structured patterns that repeated with mathematical precision. Dr. Frank Drake's pioneering work in the 1960s established the fundamental principles that guide the search for extraterrestrial intelligence. His famous equation attempts to calculate the probability of detecting artificial signals from other worlds by considering factors like star formation rates, planetary development, and the likelihood that technological civilizations develop radio communication. But Drake's protocols assume we're listening for signals intended to be heard, deliberate attempts at interstellar communication from civilizations actively seeking contact with other worlds. The object wasn't broadcasting to anyone, it was having a conversation. The signal analysis revealed patterns that matched no known natural phenomena. Hydrogen alpha emissions typically occur when hydrogen atoms absorb and re-emit specific wavelengths of light, creating the characteristic red glow seen in nebulae and star-forming regions. These emissions follow quantum mechanical rules that produce predictable spectral signatures. Beautiful, but essentially random from a communications perspective, this visitor produced hydrogen alpha bursts in sequences that followed mathematical progressions, prime numbers, Fibonacci sequences, binary patterns that corresponded to fundamental constants in physics and chemistry. The timing proved even more significant. Each burst lasted exactly 1.2 seconds, followed by intervals that varied according to complex algorithms. The pattern repeated every 11 minutes and 37 seconds with atomic clock precision, a temporal structure that suggested synchronized communication between multiple systems. Dr. Jill Tarter, the astronomer who spent decades leading CT research at the Allen Telescope Array, developed criteria for distinguishing artificial signals from natural phenomena. Genuine extraterrestrial communications, according to her analysis, would demonstrate several key characteristics: narrow bandwidth transmission, structured information content, and persistence over extended observation periods. Our interstellar visitor met all three criteria while adding a fourth that Tarter hadn't anticipated. The signals appeared to respond to Earth's own electromagnetic emissions. The correlation became apparent when researchers compared the object's transmission schedule with Earth's daily communication patterns. The strongest burst sequences occurred during peak satellite communication periods, when GPS networks, television broadcasts, and internet traffic created maximum electromagnetic activity in Earth's local environment. During quiet periods, when fewer human-generated signals filled the radio spectrum, the visitor reduced its transmission intensity accordingly. This adaptive behavior suggested either remarkable coincidence or deliberate monitoring of Earth's technological infrastructure. The object appeared to be modulating its own signals to avoid interference with human communications while ensuring its transmissions would be detectable by sufficiently sensitive equipment. The frequency analysis revealed another puzzling characteristic. Most SETI research focuses on the waterhole, a quiet region of the electromagnetic spectrum between hydrogen and hydroxyl emission lines where natural cosmic interference is minimal. This frequency range, approximately 1420 to 1720 MHz, represents an ideal channel for interstellar communication. The mysterious object transmitted across multiple frequencies simultaneously, including several that penetrate Earth's atmosphere with minimal attenuation. The signal strength suggested transmission power far exceeding what any known natural process could generate from an object of this estimated mass. But the most disturbing discovery emerged when researchers analysed the information content of the transmissions themselves. Dr. Seth Shostak, former senior astronomer at the SETI Institute, spent decades developing algorithms to detect patterns in cosmic radio noise that might indicate artificial origin. His work focuses on distinguishing random electromagnetic fluctuations from structured information, the difference between static and signal. The data streams from our interstellar visitor contain nested patterns of increasing complexity. Simple mathematical sequences gave way to more sophisticated algorithms that seemed to build upon previous transmissions. The object appeared to be conducting a systematic tutorial in mathematical concepts, starting with basic arithmetic and progressing toward advanced physics and chemistry. This pedagogical approach mirrors proposals for interstellar communication protocols designed to establish common, mathematical understanding between civilizations with no shared cultural context. The concept assumes that mathematical truths, prime numbers, physical constants, geometric relationships, represent universal languages that any technological civilization would recognize. But the visitor wasn't teaching, it was testing. The signal patterns included gaps, incomplete mathematical sequences that seem to invite completion by the receiving civilization. Problems posed in mathematical notation that any sufficiently advanced species should be able to solve. Questions embedded in electromagnetic patterns that probed the recipient's understanding of physics, chemistry, and information theory. Dr. Paul Horowitz, who designed the Meta and Beta programs at Harvard's Oak Ridge Observatory, recognized similar patterns in his analysis of the famous WOW, signal detected in 1977. That 72-second burst of narrowband radio energy from the constellation Sagittarius demonstrated characteristics consistent with artificial origin, but disappeared before confirmation could be obtained. The key difference: the WOW. Signal appeared once and never repeated, despite decades of continued monitoring. The object maintained its structured transmissions throughout its entire 19-day observation period. The implications became clear when researchers realized the visitor's emission patterns contained references to Earth's own technological development. Embedded within the mathematical sequences were constants that corresponded to the electromagnetic signatures of human satellite communications, GPS timing protocols, and cellular network frequencies. The interstellar object knew what our technology looked like. It understood how we generate and process electromagnetic signals, and it was demonstrating that knowledge through communication protocols that revealed intimate familiarity with human engineering approaches. This suggested surveillance capabilities that extended far beyond passive observation. The object appeared to have analysed Earth's electromagnetic emissions and adapted its own communication methods to match our technological parameters. The temporal precision of the transmissions provided additional evidence of sophisticated engineering. Natural astronomical phenomena that produce regular signals, pulsars, variable stars, rotating planets, all show gradual timing drift as rotational energy dissipates or orbital mechanics evolve over time. Our mysterious visitor showed no temporal drift whatsoever. The 11-minute 37-second cycle maintained perfect regularity throughout the entire observation period, suggesting internal chronometry more precise than atomic clocks and immune to the gravitational stresses that affect objects moving through the solar system. Dr. Dan Wertheimer, who directs SETI research at the University of California, Berkeley, noted that such temporal precision requires active stabilization systems that consume significant energy. Natural objects don't maintain synchronized timing across multiple subsystems without continuous power input and sophisticated control mechanisms. The power requirements alone suggested technology far beyond current human capabilities. The signal strength measurements indicated transmission power in the gigawatt range, equivalent to the output of nuclear power plants, sustained for weeks from an object with no visible propulsion system or external power source. But perhaps most unsettling was the discovery that our visitor wasn't broadcasting randomly into space. The transmission patterns showed directional characteristics that suggested targeted communication with specific recipients. Radio telescope arrays capable of determining signal directionality revealed that the object oriented its strongest transmissions toward empty regions of space in the constellation Lyra, the same direction from which it had originally approached our solar system. It was reporting home. The mathematical content of these directed transmissions differed significantly from the signals detected by Earth-based receivers. Where the Earth-directed signals contained tutorials and tests, the Lyra-directed transmissions carried compressed data packets that suggested detailed information transfer. Reconnaissance reports: the time delay for signals travelling from Earth to Lyra at the speed of light approaches 25 years. This means any response to the object's transmissions wouldn't reach our solar system until 2049, assuming the recipients responded immediately upon receiving the report. But the discovery of our visitor's communication capabilities raises questions about whether this response timeline matters. If the object represented advanced reconnaissance technology, its mission may have been complete the moment it began transmitting structured data back to its origin point. The implications extend beyond simple espionage. Our interstellar visitor demonstrated communication protocols that combined multiple technological capabilities: power generation, signal processing, directional transmission, temporal synchronization, and adaptive signal modulation. This integration suggests manufacturing capabilities and engineering knowledge that exceed current human technology by centuries. Yet the object allowed itself to be detected and observed by Earth's primitive monitoring systems. It transmitted signals using frequencies and protocols that human technology could receive and analyze. It provided enough information to demonstrate its artificial nature while withholding enough to prevent comprehensive understanding. This combination of revelation and concealment suggests a communication strategy designed to accomplish specific objectives, demonstrate technological superiority, gather intelligence about human capabilities, and establish the foundation for future contact under carefully controlled conditions. Dr. Carl Sagan, in his novel Contact, envisioned first contact with extraterrestrial intelligence as a received signal containing instructions for building advanced technology. The aliens in Sagan's scenario provided humans with the tools needed to join a galactic community of technological civilizations. Our mysterious visitor represented a different approach, intelligence gathering disguised as accidental encounter. The object revealed enough of its capabilities to demonstrate advanced technology while collecting detailed information about human detection methods, response protocols, and communication systems. If this interpretation is correct, then our visitor succeeded in accomplishing something unprecedented in human history. First contact achieved through deception rather than invitation. The questions that emerge from this possibility challenge every assumption about interstellar communication and the motives of advanced civilizations. Why gather intelligence covertly rather than establish open communication? What information could Earth's primitive technology provide to a civilization capable of interstellar travel? And most troubling, what happens when the reconnaissance data reaches its intended recipients and they begin planning their response? Tonight, as radio telescopes around the world continue their systematic search for artificial signals from other worlds, operators have begun monitoring frequency ranges and signal patterns identified during the observations of our interstellar visitor. They listen for responses, acknowledgements, or additional probe transmissions that might indicate ongoing surveillance activities. The search for extraterrestrial intelligence has traditionally focused on detecting civilizations attempting to announce their presence to the universe. But our recent visitor suggests a different paradigm: advanced civilizations that prefer to remain hidden while studying younger species that haven't yet learned the value of silence in a universe where not all watchers are friendly. The signals have stopped. The object has vanished beyond detection range. But somewhere in the direction of Lyra, approximately 25 light-years from Earth, data packets containing detailed information about human technology are racing through interstellar space at the speed of light. And in facilities we can't imagine, using technologies we don't understand, someone, or something, is learning everything they need to know about us. During World War II, submarine warfare taught navies a fundamental lesson about survival in hostile territory: never ping first. Sonar operators could send out active pulses to map their surroundings, revealing the location of enemy vessels, underwater obstacles, and safe passages. But each pulse also announced their own position to anyone listening. In the dark depths of the ocean, the submarines that survived were those that learned to listen rather than broadcast, to remain invisible rather than illuminate their environment. By March 2024, humanity had been pinging the universe for nearly a century. Our radio telescopes don't just listen, they transmit. Planetary radar systems bounce signals off asteroids and planets to map their surfaces. The Arecibo message, transmitted in 1974, deliberately announced our presence to anyone within 25,000 light-years of Earth. Television broadcasts, GPS satellites, and cellular networks have been leaking electromagnetic radiation into space since the 1950s, creating an expanding bubble of artificial signals that now extends over 70 light-years in every direction. We've been telling the universe exactly where we are, what our technology looks like, and how advanced our civilization has become. But what if we were never supposed to be the ones doing the talking? The analysis of our interstellar visitors' communication patterns revealed a disturbing possibility. The object wasn't trying to contact Earth. We had intercepted something never intended for our receivers. The structured mathematical sequences, the precisely timed bursts, the directional transmissions toward Lyra, all suggested a communication protocol designed for recipients with technology far more sophisticated than ours. We had accidentally eavesdropped on a conversation between entities that assumed we weren't capable of listening. Dr. Michael Michaud, former director of the Office of Space and Advanced Technology at the State Department, spent decades studying the implications of contact with extraterrestrial intelligence. His work focuses on what he calls the contact scenario, the political, social, and technological consequences of detecting artificial signals from other worlds. But Michaud's protocols assume intentional contact, civilizations deliberately attempting to communicate across interstellar distances. They don't address the possibility of accidental interception, stumbling across communications never meant to be heard by primitive species still learning to distinguish signal from noise. The intelligence community understands this problem intimately. During the Cold War, some of the most valuable intelligence came not from intercepting messages intended for enemy forces, but from accidentally receiving communications that revealed capabilities, locations, and intentions their adversaries never intended to share. The Soviets' early missile tests were detected not through deliberate signals intelligence, but by American radar operators, who happened to be monitoring the right frequencies at the right time. These accidental intercepts provided crucial information about launch trajectories, payload capabilities, and testing schedules, intelligence that shaped military strategy for decades. But intelligence gathering operates under a fundamental assumption. Both sides understand they're engaged in espionage. The consequences of detection are political embarrassment, diplomatic tension, or strategic disadvantage. When the stakes involve interstellar communication, the consequences of accidental eavesdropping become impossible to predict. The mathematical content of our visitors' transmissions suggests communication between entities operating on technological scales that dwarf human capabilities. The power requirements alone, sustained gigawatt-range transmission from a relatively small object, indicate engineering capabilities centuries beyond current human achievement. If such entities intended their communications to remain private, discovering that a primitive species had accidentally intercepted and analysed their transmissions might provoke responses we're not prepared to handle. Consider the implications from their perspective. A young civilization has demonstrated the ability to detect stealth technology, analyse encrypted communications, and reverse engineer transmission protocols. From a security standpoint, we've just announced that humanity represents a potential intelligence-gathering threat. The timing of our visitor's appearance becomes significant in this context. The object arrived during a period of maximum human technological development, sophisticated enough to detect anomalous signals, advanced enough to analyze complex data patterns, but still primitive enough to broadcast our capabilities openly rather than maintaining operational security. It's as if someone wanted to test exactly how much we could see and understand, while ensuring we would inevitably reveal the extent of our surveillance capabilities. The historical precedent is troubling. In 1960, American intelligence agencies detected and tracked a Soviet satellite that appeared to be malfunctioning. The object transmitted irregular signals, followed an unstable orbit, and seemed to violate known principles of spacecraft design. For months, analysts assumed they were observing technological failure. Only later did they realize the malfunctioning satellite was actually a highly sophisticated reconnaissance platform, specifically designed to appear broken while conducting detailed surveillance of American military installations. The deception succeeded because American observers applied their own technological limitations to interpret foreign capabilities. Our interstellar visitor may represent a similar deception operating on a cosmic scale. An object designed to appear sufficiently anomalous to attract attention from emerging technological civilizations, while secretly conducting comprehensive surveillance of their detection capabilities, communication protocols, and response procedures. The mathematical sequences in the object's transmissions weren't tutorials intended to educate humanity about universal constants. They were diagnostic tests designed to measure our analytical capabilities, determine our understanding of physics and mathematics, and assess our potential for technological development. Each incomplete sequence represented a probe. How quickly could we identify the missing elements? What level of mathematical sophistication did our responses demonstrate? How effectively could we distinguish artificial patterns from natural phenomena? By responding to these tests, even internally through our own research and analysis, we provided detailed intelligence about human cognitive capabilities, scientific methodologies, and technological infrastructure. The object's adaptive transmission schedule, correlating with Earth's communication patterns, suggests even more sophisticated intelligence gathering. By monitoring when and how we generate electromagnetic signals, the visitor mapped our daily technological routines, identified our primary communication systems, and catalogued the timing patterns of our satellite networks. This information would prove invaluable for any civilization planning future contact or surveillance operations. They now know when Earth's defenses are most active, which frequencies we monitor most carefully, and how quickly we respond to anomalous signals. But perhaps most significantly, they know we don't understand the rules of cosmic operational security. The concept of dark forest theory, popularized by Chinese science fiction author Liu Cixin, suggests that the universe operates like a forest at night. Every civilization represents a potential threat to every other civilization, and survival depends on remaining hidden until you're powerful enough to eliminate competitors. In this framework, the civilizations that survive are those that perfect stealth technology, avoid broadcasting their locations, and eliminate emerging threats before they become dangerous. Young civilizations that announce their presence through radio signals, space exploration, or attempts at interstellar communication mark themselves for observation and eventual elimination. Our interstellar visitors' behavior aligns perfectly with dark forest protocols, remain undetected during reconnaissance, gather comprehensive intelligence about potential threats, and report findings to decision-makers who determine appropriate responses. The 25-year communication delay to Lyra means we won't detect any immediate response to the object's reconnaissance report, but this timeline may be irrelevant if the visitors employ technology beyond our current understanding, faster-than-light communication, pre-positioned monitoring stations, or automated response systems that don't require approval from their point of origin. The most unsettling possibility is that we're not the first emerging civilization they've encountered. The object's sophisticated testing protocols suggest extensive experience evaluating the capabilities of young species. The mathematical sequences, adaptive communication methods, and precision timing all indicate refined techniques developed through multiple previous encounters. If so, then humanity has just undergone a cosmic assessment whose criteria and consequences remain unknown. We've been evaluated by entities operating according to survival strategies we don't understand, using technological capabilities we can't match, to determine our status in a cosmic hierarchy we're not aware exists. The visitor's disappearance from our detection systems may represent the end of the assessment phase and the beginning of the decision phase. Somewhere in the direction of Lyra, intelligence analysts are reviewing detailed reports about human technological capabilities, communication protocols, and security awareness. They're determining whether humanity represents a future ally, a manageable neighbour, or a threat requiring elimination while we're still containable. Dr. Carl Sagan often spoke about the importance of cosmic perspective, understanding humanity's place in the vast scale of space and time, but his vision assumed benevolent contact with civilizations eager to welcome newcomers into a galactic community of mutual cooperation and shared knowledge. Our accidental interception of the visitor's communications suggests a different cosmic reality, a universe where advanced civilizations operate according to strategic principles that prioritize survival over cooperation, where contact occurs through deception rather than invitation, and where the consequences of being discovered depend on evaluations conducted in secret by entities whose motives remain unknowable. The submarine warfare analogy becomes prophetic. We've been pinging the cosmic ocean for decades, announcing our location to anyone capable of listening. But we've only recently developed the capability to detect when others are pinging back, or worse, when they've been listening silently all along. Tonight, as our radio telescopes continue their search for artificial signals from distant worlds, we must confront an uncomfortable possibility. The signals we're looking for may already be surrounding us, carried by objects designed to remain undetected until their surveillance missions are complete. The question is no longer whether we're alone in the universe. The question is whether we've just discovered that we never were alone, and whether the entities who've been watching us have now decided we've learned too much to remain safely ignorant. In the depths of space, far beyond our ability to detect or intercept, reconnaissance reports are travelling towards civilizations whose response protocols were established long before humanity developed the capability to accidentally overhear their communications. We opened a letter that was never addressed to us. Now we wait to discover what happens when the senders learn we know how to read. In the pre-dawn darkness of 9,500 BC, while the last ice sheets retreated across Europe and humanity's total population numbered less than 5 million, someone was moving massive stone blocks across the hills of southeastern Turkey. The builders of Göbekli Tepe arranged 20-ton limestone pillars in precise geometric patterns, carved intricate reliefs of animals and symbols, and aligned their structures with specific constellations in the night sky. Then they buried it all under tons of earth and walked away. For over 11,000 years, this sophisticated complex remained hidden beneath what appeared to be a natural hillside. No farming communities existed nearby. No trade routes passed through the region. No logical reason explained why hunter-gatherers would invest generations of labour in creating something so monumental, so precise, so deliberately concealed from future discovery. Unless they were responding to instructions from watchers who preferred to remain unseen. Our detection of the interstellar visitor in 2024 may represent humanity's first accidental glimpse behind a cosmic curtain that has been carefully maintained for millennia. But the evidence suggests this wasn't our first encounter, merely our first time possessing the technology to recognize what we were looking at. Ancient astronomical records from civilizations across the globe contain references to objects that move through the sky in ways that defied contemporary understanding. The Chinese astronomical text Zhoubi Suanjing, dating to 300 BC, describes guest stars that appeared in specific locations, maintained constant brightness for precise periods, then vanished without leaving observable remnants. Unlike novae or supernovae, which follow predictable patterns of emergence and decay, these guest stars appeared and disappeared according to schedules that seemed calculated rather than natural. The Chinese astronomers noted that these objects often coincided with significant cultural or technological developments, the introduction of new agricultural techniques, the development of metallurgy, or the emergence of written language. Babylonian cuneiform tablets from the Library of Ashurbanipal describe similar phenomena. The Mullapin astronomical texts reference divine messengers that crossed the sky at specific intervals, carrying information between the realm of the gods and the human world. These objects demonstrated behaviour that required the viewers to possess advanced mathematical knowledge to predict their appearances, knowledge that supposedly didn't exist among Bronze Age civilizations. But perhaps most intriguing are the records that describe what happened after these appearances. The Sumerian Epic of Gilgamesh, dating to approximately 2100 BC, includes passages describing how the hero acquired advanced knowledge after witnessing the boat of heaven cross the night sky. The text suggests that certain technological developments, irrigation systems, urban planning, advanced mathematics, emerge not through gradual cultural evolution, but through sudden acquisition of sophisticated concepts that required generations to fully implement. Egyptian hieroglyphic texts from the Middle Kingdom period describe Neteru boats that sailed among the stars, carrying observers who monitored human development and occasionally provided guidance to emerging civilizations. The pyramid texts, among the oldest religious writings known to humanity, contain mathematical relationships and astronomical alignments that suggest knowledge of planetary mechanics centuries before the development of telescopes. These ancient accounts share several characteristics that align disturbingly well with our recent visitors' behaviour. Objects that appeared according to calculated schedules demonstrated impossible flight characteristics and seemed to correlate their appearances with humanity's technological development phases. The pattern suggests surveillance operations conducted across geological timescales, with contact protocols designed to remain invisible to primitive observation methods while providing precisely calibrated assistance to emerging civilizations. Consider the implications. What if the technological leaps that define human history, agriculture, metallurgy, written language, mathematics, astronomy, didn't develop through random cultural evolution? What if they resulted from carefully timed interventions by civilizations monitoring our species' development according to protocols established before recorded history began? The archaeological evidence becomes disturbing when viewed through this lens. Göbekli Tepe predates agriculture by over 1,000 years, yet required sophisticated planning, advanced engineering techniques, and coordinated labour forces that supposedly didn't exist among hunter-gatherer societies. Stonehenge demonstrates astronomical alignments that require understanding of planetary mechanics, seasonal variations, and long-term celestial cycles. The builders arranged multi-ton stones with precision that demands knowledge of mathematics, engineering, and astronomy supposedly not developed until millennia later. The Antikythera mechanism, dating to approximately 100 BC, represents computational technology that wouldn't appear again until the development of mechanical clocks in medieval Europe. This bronze device could predict eclipses, track planetary motions, and calculate astronomical events decades in advance, using gear ratios and mechanical principles that suggest technological knowledge centuries ahead of its time. These artifacts don't represent gradual technological development. They appear suddenly in the archaeological record, demonstrate capabilities that exceed their contemporary civilization's supposed knowledge base, then disappear without direct successors for extended periods. It's as if someone was periodically providing humanity with technological samples, advanced enough to accelerate development, but limited enough to prevent dependence on external assistance. The timing of these interventions follows patterns that suggest deliberate scheduling rather than random cultural evolution. Major technological advances appear at intervals that correlate with astronomical cycles, climate changes, and population milestones that would make civilizations ready for increased complexity without overwhelming their social structures. Native American petroglyphs throughout the southwestern United States depict objects that don't correspond to any known natural phenomena or contemporary technology. The Hopi describe star beings who traveled in flying shields and provided guidance about agriculture, astronomy, and spiritual development. These accounts include specific details about the visitor's appearance schedule, returning every few generations to assess progress and provide additional instruction. Aboriginal Australian Dreamtime stories, passed down through oral tradition for over 40,000 years, describe sky beings who monitored human development and occasionally intervened to provide knowledge about survival techniques, territorial boundaries, and social organisation. The Aboriginal astronomical traditions demonstrate sophisticated understanding of stellar mechanics, navigation principles, and long-term climate patterns that require generations of careful observation and mathematical analysis. Polynesian navigation techniques allow voyagers to cross thousands of miles of open ocean using only observations of stars, wave patterns, and bird flight paths. These skills require integration of astronomy, meteorology, oceanography, and mathematics that supposedly developed independently among island civilizations with no contact with advanced continental cultures. The pattern emerges across every inhabited continent. Civilizations develop sophisticated knowledge that exceeds their apparent technological foundations, often following encounters with objects or entities described in terms that suggest advanced technology disguised as supernatural intervention. But our modern detection of the interstellar visitor represents something unprecedented in this historical pattern: accidental surveillance of the surveillance systems themselves. Previous encounters occurred when humanity lacked the technological capability to analyze visitors' true nature. Ancient civilizations interpreted advanced technology through religious and mythological frameworks because they had no scientific context for understanding what they observed. The 2024 detection occurred at a unique moment in human development, sophisticated enough to recognize artificial signals and analyze technological capabilities, but still primitive enough to accidentally reveal our surveillance methods to entities who expected to remain undetected. We've broken the protocol that has governed human-visitor interactions for millennia. The visitor's communication patterns, directing signals toward Lyra while conducting tests of human capabilities, suggest reporting procedures that have been refined through extensive experience with emerging civilizations. The mathematical sequences weren't educational materials. They were assessment protocols designed to measure our technological development against predetermined benchmarks. Those benchmarks may determine our species' readiness for more direct contact, continued covert monitoring, or elimination as a potential future threat. The historical record suggests that civilizations reaching our current level of development face evaluation periods that determine their continued survival. The archaeological evidence shows that some societies received continued guidance and support, while others disappeared suddenly despite apparent technological sophistication. The Maya developed advanced mathematics, astronomy, and engineering, then abandoned their cities suddenly around 900 AD. The Indus Valley Civilization created sophisticated urban planning, standardized measurements and advanced metallurgy, then vanished without trace around 1900 BC. Easter Island's inhabitants demonstrated remarkable engineering capabilities, then experienced catastrophic population collapse that left their technological achievements as isolated mysteries. What if these weren't random collapses due to environmental or social factors? What if they represented the results of cosmic evaluation processes, civilizations that failed assessments and were deemed unsuitable for continued development? The visitors' 19-day observation period, followed by sudden disappearance and communication blackout, may represent the completion of an assessment phase whose results determine humanity's continued existence. We've accidentally revealed that our species possesses surveillance capabilities, analytical intelligence, and technological development rates that may exceed the parameters established for safe monitoring of emerging civilizations. The entities directing these operations have maintained successful observation protocols for millennia, by ensuring that contact occurred only when target civilizations lacked the capability to detect and analyze the true nature of their visitors. Religious and mythological interpretation provided perfect camouflage for technological intervention. But we've demonstrated that humanity can now recognize artificial signals, reverse engineer communication protocols, and analyze technological capabilities that exceed our own. From the perspective of civilizations operating according to cosmic security protocols, we've just announced that continued covert monitoring is no longer possible. They face a decision: reveal themselves openly and risk losing operational security for monitoring other emerging species, eliminate the threat we represent before we develop capabilities that could compromise their surveillance networks, or implement more sophisticated concealment technologies that assume we're now actively searching for evidence of their activities. The archaeological record suggests that civilizations facing this decision point don't always survive the evaluation process. Tonight, as you look up at stars that have witnessed the rise and fall of countless civilizations, consider that our recent visitor may represent the final phase of a monitoring protocol that has guided human development since our species first began creating tools and building communities. We've accidentally graduated from subjects under observation to potential threats requiring management, and somewhere in the direction of Lyra, entities who have been watching humanity develop for thousands of years are now deciding whether our continued existence aligns with their long-term strategic interests. The ancient eyes that watched our ancestors build Göbekli Tepe, navigate the Pacific Ocean, and develop mathematics are now evaluating whether the species they've guided for millennia has become too dangerous to permit further technological advancement. Our first glimpse behind the cosmic curtain may also be our last. On June 28, 1914, Archduke Franz Ferdinand's driver made a wrong turn in Sarajevo. The intended route would have taken them safely past cheering crowds and ceremonial displays. Instead, they found themselves on a narrow side street where a 19-year-old Serbian nationalist named Gavrilo Princip happened to be eating lunch at a cafe. The wrong turn brought the Archduke's car to a complete stop directly in front of the most dangerous person in the city at that precise moment. 2 gunshots. 37 days later, the world was at war. Sometimes the most catastrophic events in history begin with small errors that cascade through systems no one fully understands. A driver's mistake, a detection algorithm that flagged an anomaly, a civilization that accidentally intercepted communications never meant for their analysis. Since April 3, 2024, the day our interstellar visitor vanished from detection systems, a series of seemingly unrelated anomalies have begun appearing in monitoring data from observatories, satellite networks, and deep space surveillance systems around the world. At first, the incidents appeared random: equipment malfunctions, software glitches, natural phenomena producing unusual but explainable results. But when analysed together, they reveal patterns that suggest our accidental eavesdropping on cosmic communications may have triggered consequences we're only beginning to recognise. The first anomaly occurred 72 hours after the visitor's disappearance. The Deep Space Network facility in Goldstone, California, detected a brief radio signature that lasted exactly 1.2 seconds, the same duration as the structured burst from our departed visitor. The signal appeared on multiple frequencies simultaneously, demonstrated the same mathematical precision, but originated from empty space in the constellation Cygnus. When operators attempted to verify the detection, their equipment registered only cosmic background radiation. but the automated systems had recorded data patterns that matched the visitors' communication protocols with atomic precision. Similar detections began appearing at radio telescope facilities worldwide. The Very Large Array in New Mexico, the Parkes Observatory in Australia, the FAST telescope in China. Each facility recorded brief, structured signals that followed the mathematical sequences established during the visitors' 19-day observation period. But these new signals carried a disturbing difference. They were responses. Dr. Dan Wertheimer's SETI team at Berkeley analysed the signal patterns and discovered they contained mathematical solutions to the incomplete sequences our visitor had transmitted toward Earth. Problems that had been posed as tests were now being answered by entities demonstrating computational capabilities far exceeding human mathematical knowledge. The responses weren't coming from Lyra. They originated from multiple directions simultaneously: Cygnus, Vega, Altair, Proxima Centauri, as if a network of monitoring stations scattered throughout local space was suddenly revealing their existence. We had accidentally triggered an awakening. The timeline becomes more disturbing when correlated with changes in satellite behavior. Between April and August 2024, 37 Earth-orbiting satellites experienced unexplained malfunctions that forced emergency shutdowns of critical systems. Communications satellites lost signal lock. GPS networks showed timing anomalies that lasted exactly 11 minutes and 37 seconds. Weather monitoring systems recorded data patterns that suggested external electromagnetic interference. The malfunctions followed no pattern related to solar activity, cosmic ray bombardment, or mechanical failure. Instead, they appeared to occur when satellites passed through specific orbital positions that aligned with the directions from which the new radio signals were being detected. It was as if something was systematically testing our orbital infrastructure. The European Space Agency's Mars Express orbiter recorded even more troubling data. During routine imaging of the Martian surface in July 2024, the spacecraft detected geometric patterns in the regolith near Olympus Mons, straight lines, perfect circles, and angular structures that appeared artificial in origin. When mission controllers directed the orbiter to photograph these features in higher resolution, the patterns had vanished. Subsequent images showed only natural geological formations with no trace of the geometric anomalies recorded weeks earlier. But the most unsettling developments occurred in Earth's upper atmosphere. High-altitude surveillance aircraft operated by various national intelligence agencies began detecting radar signatures that corresponded to objects moving at velocities that exceeded known technological capabilities. These contacts appeared briefly, demonstrated flight characteristics that violated aerodynamic principles, then disappeared before detailed tracking could be established. The objects didn't follow random flight paths. They conducted systematic surveys of major population centers, strategic military installations, and space-based communication facilities. The survey pattern suggested intelligence-gathering operations conducted by entities with intimate knowledge of human technological infrastructure. Government space surveillance networks, designed to track everything from debris fragments to classified military satellites, began reporting phantom contacts, radar signatures that appeared genuine during detection but couldn't be verified through optical tracking or secondary sensor systems. These phantom contacts demonstrated behavioral patterns that seemed designed to probe the response capabilities of Earth's defense networks. They appeared at altitudes and velocities that required immediate military response, then vanished precisely when interceptor aircraft reached their projected locations. The pattern suggested entities testing our reaction times, response protocols, and defensive capabilities while remaining just beyond our ability to confirm their existence. Commercial aviation began experiencing unexplained phenomena that followed similar patterns. Pilot reports described objects that paced aircraft at distances just beyond visual confirmation, matched their speed and altitude exactly, then accelerated beyond tracking capability when passengers or crew attempted to record evidence. These encounters occurred primarily on routes that connected major technology centers: Silicon Valley to Boston, London to Geneva, Tokyo to Seoul, as if someone was monitoring transportation corridors used by personnel working on advanced scientific and engineering projects. The shipping industry reported comparable experiences. Container vessels crossing Pacific and Atlantic trade routes detected radar contacts that shadowed their movements for extended periods, maintaining precise distances that avoided visual confirmation while demonstrating knowledge of shipping schedules and cargo manifests that couldn't be obtained through passive observation. But perhaps most disturbing were the changes in deep space observation data. Astronomical surveys that had been monitoring the same regions of sky for decades began detecting objects that appeared in historical images but had never been catalogued. When researchers reviewed archival data from the Hubble Space Telescope, the Spitzer Space Telescope, and ground-based observatories, they found evidence of structured objects that had been present in hundreds of images spanning 30 years of observation. These objects had been invisible to automated detection algorithms, but became apparent when human analysts applied pattern recognition techniques developed during the analysis of our interstellar visitor. The shapes were geometric, artificial in appearance, and positioned in locations that provided optimal observation angles for monitoring Earth's technological development. We had been under continuous surveillance for decades. We simply lacked the analytical tools to recognize what was hiding in plain sight. The implications extend beyond simple reconnaissance. The systematic nature of these revelations suggests a coordinated response to humanity's demonstration of enhanced detection capabilities. Entities that had maintained successful concealment for extended periods were now revealing their presence in carefully controlled stages. Each new detection provided additional evidence of monitoring activities while ensuring that verification remained just beyond definitive confirmation. Phantom radar contacts, brief signal detections, geometric anomalies that vanished before detailed analysis could be completed. It was as if someone wanted us to know we were being watched, while maintaining plausible deniability about the watcher's true nature and capabilities. The cascade failure theory from complex systems analysis provides a framework for understanding these developments. When critical components in interconnected networks experience failure, the consequences propagate through associated systems in ways that can't be predicted from analysing individual components in isolation. Our accidental detection of the visitor represents the initial failure point in a cosmic surveillance network that had been operating successfully for millennia. The network's response, revealing additional monitoring stations, testing our defensive capabilities, conducting systematic surveys of our infrastructure, represents cascade failures propagating through systems we didn't know existed. But cascade failures in complex systems don't just reveal hidden components. They force system-wide reconfigurations that can eliminate the original failure points entirely. The visitor's response to our enhanced detection capabilities may be preparing for a re-engineering of their surveillance protocols that eliminates the possibility of future accidental discoveries. This could involve developing more sophisticated concealment technology, relocating monitoring operations beyond our detection range, or removing the source of the security breach entirely. Historical precedent suggests the third option represents standard procedure for intelligence operations that experience security compromises. During the Cold War, when American intelligence agencies discovered that their communications had been intercepted by foreign adversaries, the standard response involved eliminating the sources of the security breach through methods ranging from diplomatic pressure to covert operations that neutralized the threat permanently. Applied to cosmic intelligence operations, this precedent suggests entities whose surveillance networks have been compromised might consider eliminating the civilization that demonstrated unexpected detection capabilities. The 25-year communication delay to Lyra means any coordinated response to our visitor's reconnaissance report won't arrive until 2049. But the systematic nature of current monitoring activities suggests that response protocols don't require approval from central authorities. Local monitoring stations may be authorized to implement threat neutralization procedures when emerging civilizations demonstrate capabilities that compromise operational security. The timeline suggests we're experiencing the initial phases of such protocols: enhanced surveillance to catalogue our complete technological infrastructure, systematic testing of our defensive capabilities, detailed analysis of our communication networks and response procedures, intelligence gathering that precedes operational planning. Tonight, as automated systems around the world continue recording anomalies that can't be officially acknowledged or definitively explained, we must confront the possibility that our accidental discovery has initiated processes we can't control or fully understand. We made a wrong turn in the cosmic city and found ourselves face to face with entities who prefer to remain unobserved. Now we're learning what happens when civilizations stumble across surveillance networks they were never meant to detect. The cascade has begun. The question isn't whether we can stop it, but whether we'll survive long enough to understand what we've accidentally set in motion. In facilities we can't locate, using technologies we can't comprehend, strategic planners are calculating the cost of eliminating a security risk that doesn't yet understand the rules of the game it's accidentally joined. The error chain that began with our detection of an interstellar visitor is approaching critical decision points whose outcomes will determine whether humanity's first glimpse behind the cosmic curtain becomes our last. Every lighthouse was built to warn ships away from danger. The beam that sweeps across dark waters isn't an invitation, it's a boundary marker, announcing the presence of rocks that will destroy anything that comes too close. For centuries, sailors have understood this fundamental rule. When you see the light, you change course. You don't sail toward the beacon to investigate its source. But on March 15th, 2024, humanity spotted a lighthouse beam that wasn't built for us, and instead of changing course, we pointed every telescope we could find directly at the source. Now we're learning what happens when curious civilizations ignore cosmic warning systems they were never meant to detect. The 19 days we observed our interstellar visitor represent a turning point in human history, as significant as the development of agriculture or the splitting of the atom. Not because we discovered evidence of extraterrestrial technology, but because we accidentally revealed that we had developed the capability to detect evidence of extraterrestrial technology. In cosmic terms, we just announced that humanity had graduated from subjects under observation to potential participants in surveillance operations we didn't know existed. The question isn't what our visitor was or where it came from. The question is whether civilizations that stumble across monitoring networks they were never supposed to see get invited to join the Watchers or eliminated as security risks. The evidence suggests both possibilities remain open. Dr. Frank Drake's famous equation attempts to calculate the probability of detecting extraterrestrial civilizations by multiplying factors like star formation rates, planetary development, and the likelihood that life evolves intelligence. But Drake's framework assumes random distribution of civilizations across the galaxy, independent development of technology, and equal probability of contact between any two species. Our recent experience suggests a different model entirely, a managed galaxy where advanced civilizations actively monitor younger species, guide their development according to established protocols, and maintain strict operational security to prevent accidental detection by subjects who aren't ready for direct contact. This framework explains several puzzles that have confounded researchers for decades. The Fermi paradox asks why we haven't detected evidence of extraterrestrial civilizations despite the vast number of potentially habitable worlds in our galaxy. But if advanced civilizations have perfected stealth technology and prefer covert observation to open communication, the absence of detectable signals becomes evidence of sophisticated operational security rather than evidence of cosmic loneliness. The Great Silence, the apparent lack of artificial signals from other worlds, may actually represent the cosmic equivalent of professional intelligence operations, where successful surveillance leaves no traces that subjects can detect, until the subjects accidentally develop detection capabilities that compromise the Watcher's operational security. Our visitors' behavior patterns, communication protocols, and sudden disappearance suggest responses to a security breach, rather than completion of a routine mission. The object revealed just enough of its capabilities to demonstrate advanced technology, while gathering comprehensive intelligence about human detection methods and analytical capabilities. This combination of demonstration and intelligence gathering represents standard procedure for operations that have transitioned from covert surveillance to active threat assessment. The systematic anomalies that appeared after our visitor's departure, phantom radar contacts, satellite malfunctions, structured radio signals from multiple directions, suggest coordinated responses by entities evaluating humanity's technological infrastructure and defensive capabilities. We're being assessed by civilizations whose evaluation criteria we don't understand, using technological capabilities we can't match, to determine our classification in a cosmic hierarchy we weren't aware existed. The historical precedent is sobering. Every technological civilization in Earth's archaeological record reached a point where rapid development attracted attention from entities that provided guidance, then either continued supporting their advancement or allowed them to collapse when they exceeded safe parameters for continued independence. We may be experiencing the evaluation phase that determines whether humanity receives continued covert guidance or faces elimination as a potential future threat to galactic operational security. But our situation differs from previous civilizations in crucial ways that may work in our favour. Unlike our ancestors, who interpreted advanced technology through religious and mythological frameworks, we possess scientific methodologies capable of analysing artificial phenomena and recognising technological capabilities that exceed our own. We can distinguish between natural and artificial signals, reverse engineer communication protocols, and draw logical conclusions about the intentions and capabilities of entities operating beyond our technological reach. This analytical sophistication represents both our greatest asset and our most dangerous liability. From the Watcher's perspective, we've demonstrated intelligence-gathering capabilities that could potentially compromise their surveillance operations targeting other emerging civilizations. A species that can accidentally detect stealth technology and analyze encrypted communications represents an unknown variable in carefully controlled observation protocols. But intelligence also represents potential value. Civilizations capable of contributing to surveillance networks rather than merely requiring monitoring might qualify for recruitment rather than elimination. The mathematical sequences our visitor transmitted toward Earth weren't just diagnostic tests measuring our analytical capabilities. They were also communication protocols establishing common frameworks for more sophisticated information exchange. The incomplete sequences that seem to invite completion by human analysts may have been designed to assess our potential for collaborative intelligence operations rather than simply measuring our threat level. If our responses demonstrated sufficient analytical sophistication without suggesting aggressive intentions, we might qualify for gradual integration into galactic monitoring networks under carefully controlled conditions. This possibility aligns with patterns evident in our technological development over the past century. Many of the scientific breakthroughs that define modern civilization, quantum mechanics, nuclear physics, computer science, space exploration, emerge through sudden insights that seem to appear simultaneously in multiple research centres worldwide. What if these breakthrough moments didn't result from independent discovery, but from carefully timed information releases designed to accelerate human technological development according to predetermined schedules? The timing of our visitor's appearance during humanity's transition from primitive radio astronomy to sophisticated signal analysis capabilities suggests coordination with our developmental timeline rather than random coincidence. We may have been deliberately guided toward the detection capabilities required to recognize artificial signals, then tested to determine our readiness for more direct contact with the civilizations that have been monitoring our progress for millennia. The 25-year communication delay to Lyra means we won't detect immediate responses to our visitor's reconnaissance report. But this timeline may be irrelevant if our evaluation doesn't require approval from distant authorities. Local monitoring stations may be authorized to implement contact protocols when emerging civilizations demonstrate analytical capabilities that qualify them for recruitment into surveillance networks. The systematic nature of post-detection anomalies suggests coordinated evaluation procedures rather than threat assessment protocols. The phantom contacts, structured signals, and revealed orbital objects demonstrate advanced capabilities while avoiding actions that would trigger defensive responses or cause widespread panic. It's as if someone wants us to gradually understand that we're being observed by entities with sophisticated technology, without creating social disruption that could destabilize our civilization during the evaluation period. But this interpretation assumes benevolent intentions from civilizations whose motives and strategic priorities remain unknowable. The alternative possibility, that current activities represent preparation for elimination procedures, can't be dismissed based on hopeful speculation about cosmic benevolence. The Dark Forest theory suggests that successful civilizations eliminate potential competitors before they become dangerous. From this perspective, our demonstration of enhanced detection capabilities marks us for neutralization while we're still manageable. The evidence supports both interpretations. Enhanced surveillance could precede either recruitment or elimination. Demonstration of advanced technology could represent either invitation or intimidation. Systematic evaluation could lead to either integration or termination. The outcome may depend on factors we don't understand using criteria we can't influence through any actions available to our current technological civilization. Tonight, as you drift towards sleep in a bedroom travelling through space at 67,000 miles per hour around a star that's racing through the galaxy at 514,000 miles per hour, consider that your planet may no longer be alone in the cosmic darkness. Somewhere in the space between stars, entities with capabilities we're only beginning to glimpse are analysing data about human civilization and reaching conclusions about our species' continued existence. They're determining whether the lighthouse beam we accidentally detected represents a warning we should have heeded or an invitation we were meant to accept. The observers who have watched our ancestors develop agriculture, build monuments, and discover mathematics are now evaluating whether the species they've guided for millennia has become sophisticated enough to join their surveillance networks, or dangerous enough to require elimination. We stumbled across a cosmic monitoring system that has operated successfully for thousands of years by ensuring that emerging civilizations remained unaware of their watchers. But we've accidentally demonstrated detection capabilities that threaten the operational security those systems require to function. Now we wait to discover whether civilizations that see behind the cosmic curtain get invited to help operate the machinery, or eliminated to protect its continued concealment. The lighthouse wasn't built for us, but we saw its beam anyway, and in the months and years ahead, we'll learn what happens when curious species ignore warnings they were never meant to detect, in a universe where not all lights in the darkness mark safe harbours. The ancient eyes that watched our ancestors build their first cities are now deciding whether humanity has earned the right to become watchers ourselves, or whether we've seen too much to remain safely ignorant of the systems that govern civilizations across the galaxy. Either way, our accidental glimpse behind the cosmic curtain has changed everything. We can never again assume we're alone in the universe. We can never again assume that the objects moving through space around us follow only the laws of physics and chance. And we can never again assume that being observed means being protected. The error chain that began with our detection of an interstellar visitor is approaching its conclusion. Soon, we'll discover whether humanity's first contact with advanced extraterrestrial technology becomes the beginning of our integration into a galactic community of watchers, or the end of our existence as an independent civilization. The lighthouse beam continues sweeping through the cosmic darkness, marking boundaries we don't understand between territories controlled by entities whose purposes remain hidden behind technologies we're only beginning to comprehend. But now we know it's there, and that knowledge, more than any discovery in human history, will determine whether our species survives to see what lies beyond the light.